Hello class, welcome to our discussion today. So we are going to continue our topic on the integration by substitution, and in the case where we were given exponential functions or logarithmic functions, so we will apply rules for integrating exponential functions and functions yielding logarithmic functions. So we have here the logarithmic rule as mentioned last time. Integral of 1 over x dx equal to ln x plus c for all x not equal to 0. And if u is a differentiable function of x, then the rule becomes 1 over u, integral of 1 over u times du equal to ln u plus c. So last time I gave you one example for this topic. So today I'm going to give you another one. So this is our example number 2. So in our example number 2, we're given integral of 2x to the 4th power divided by x to the 5th power, then plus 1 times dx. So this is our given, so I'll just correct this one class, write it well. So how will we solve this problem? As in our previous example, you have to let u be equal to x to the 5th power and plus 1. So if we let this as our u, then we can now write the integral as the integral of 2x to the 4th power divided by u, because we let this x to the 5th power plus 1 as u, and then times dx. So we can, to find this or to derive this, we need to replace dx here by something that contains du, and we can find that from here, from our u. So if we take the derivative of u with respect to x, so this becomes 5x to the power 4. Now when you take the derivative of x to the power 5, so we have 5x to the power 4 plus the derivative of 1 with respect to x is equal to 0. Okay? Then solving for du, so cross multiply dx or multiply both sides by dx. So we have du equal to 5 times x to the 4th power times dx. So if you look at the result of our du, it contains x to the 4th power dx. We have here x to the 4th power dx. But the problem is we have 2, but we have here 5. So to solve this problem in a manner that we had done in our previous example, so the best thing to do here is to isolate the constant here, put it outside or on the left side of the integral sign, so that this becomes 2 times the integral of x to the 4th dx divided by u. Okay, so this is our integral times, so we just put the constant outside integral sign. Okay, I will write it properly. Just hold on class. Okay, so put the constant outside. So we have 2 times the integral of, we have 2, this is x, so no more 2, we already put that outside. So this is x to the power 4 dx, then divided by u. Now in our result, when we find du, so we have already x to the 4th times dx. So x to the 4th times dx. So to solve for x to the 4th dx, so we will divide both sides by 5. Okay, so dividing this by 5, so we have x to the 4th dx. Okay, so this is what exactly we are looking for, right? So we have here x to the 4th dx, x to the 4th dx. So we have solved this, and this one is equal to du over 5. So we have to replace this with du over 5. So this becomes 2 times the integral of du over 5, then divided by u. Okay, so again, I have to write it well because they are not. Okay, so integral of, we have here du over 5. So this is what we're going to replace for x to the 4th dx. So du over 5, and we have the constant 2 outside, then divided by u. Okay, so that's our resulting integral after the process. So our goal, class, is to obtain this, or to arrive this integral of 1 over u du, so that we can use the equivalent ln u plus c. So how are we going to do this or that? Okay, so if you look at the integrand, now it contains fraction. So that contains fraction. So if you can still remember from our algebra, so we have the numerator, which is du over 5, then our denominator is equal to u. So that u, class, is understood to be over 1. Okay? So any number divided by 1, that's the same number. So my purpose of doing that, so that we can apply the rules of division of fractions. So what was the division of fraction? What was the division of fraction, class? So the rules in dividing fraction is you invert the divisor, okay, and proceed to multiplication. So our divisor is u over 1, so we can write this as 1 over u, then times, just copy the numerator, that is du over 5. Okay? And that d over 5 is just the same as 1 over 5 times du. Okay? And since this is a constant, again, we can put this outside or on the left side of the integral sign. So we have 2 and multiplied by 1 over 5 and the integral of 1 over u times du. Okay, so we're almost there. So equal to, so 2 times 1 over 5, so that is just 2 over 5. And this is now in the form of 1 over u du. So from our rule, integral of 1 over u du, so that is equal to ln u plus c. So we can use that rule. So we can rewrite this as 2 over 5. So this is the product of this. Then times the integral of this one, which is equal to ln of u and plus c. Okay? I will continue this one here, class. So from here, Okay, I'll continue it here. So this is equal to 2 over 5 times ln. What is our u? Our u is this. Okay, this is x to the 5 plus 1. So ln u, where our u is x to the 5th power plus 1. Okay. Any question? Okay, that's it.